Hello and welcome to the first video of 2020, for me at least. I'm not saying there's not been any other videos. In this video we are going to make an RPG kind of quest compass thing, similar to what you've seen in games like Skyrim and things like that. As you can see here, I've got a little bit of a scene set up. This is entirely made from free assets from the Unity Asset Store. I can't remember the names of them all off the top of my head, but obviously links to each of them will be included in the description below. This took literally 5 minutes to set up. The scene itself, like the trees and everything, was included in the nature assets pack that I pulled, or the fantasy forest, or so. Like I said, the name will be in the description and the links. And then there was some grass footsteps, the Unity standard assets, first person controller, and I think a few other things, an icon pack, an RPG icon pack that we will get to shortly. So let's get into the video. So the first thing that we need to do, which I've actually already done, is I need to pull in some images for our compass. So the compass itself, I've just got a background. Obviously you can design this however you like, but I've designed it like this. So this is the background, and then I have this compass image here. This is the same size as the background image that I've just shown you, and the key thing about this is that the north needs to be dead center, the south needs to be split half and half on either end, and the west and east need to be in the middle of north and south. So in this case, my image is 400 pixels wide. North is obviously at 200 pixels, west is at 100, east is at 300, and then south is at 400 and 0. So that's the key element there. For this to work the way that I'm doing it, about to do it, they need to be equally spaced. You don't have to do it 400, you could do it 800, and then this would be at 400 and this would be at 200. The key thing is that this is a quarter, this is 3/4, this is half, and that's split in half. Let's drag these into our scene. And one more thing. Compass, not the compass BG, but compass itself needs to be a repeat for this to work. So if we go into here and we create a new UI element, and the UI element we want is a image, and then we will drag our compass BG onto the sprite for that, and we'll set the size, which is 400 by 40 it was? No, 30, sorry. And then we want to set the position, so I'm going to change the anchor point to the top center, and then I'm going to change the pivot to be 1, sorry, because Y is bottom to top. So 1 means that our pivot, I'll just switch this here. So that means that our pivot becomes there, like at the top center. So now I can set the X position to 0, which will put it in the middle, and then the Y position to -10, which puts it just off the top of the screen, which is about right. And I will call that compass BG, and we do not need to touch that again. Now, the important one, or the more important one, like you don't need the compass background at all. That's purely for aesthetics. But the more important one, we're going to go into UI again, and we need a raw image. And this has to be a raw image because we need access to this here. We need access to the UV rect. So we'll just call this one compass. We will set the position the same way we did for the last one. So pivot top center, Y position 1, and 400 by 30, and then -10, was it? Yeah, -10. And then we drag this in here, and we can see we have our compass set up. Now, of course, if I press play now, it doesn't do anything because it's just a static image. So let's change that. Create ourselves a scripts folder. Go into the scripts folder and create a script, which we're just going to call compass. Let's get that opened up. So the first thing we're going to need to do is include the unity.ui namespace, and then we're going to need a public reference to our raw image, which we're just going to call compass image, and a public transform reference to our player. And then this is dead simple. This in update, all we need to do is compass image dot UV rect. This is why we needed it to be a raw image, because we need to get access to this UV rect. And then we're going to set this to a new rect. Then we're going to get player dot local Euler angles dot Y, and we're going to divide that by 360. And then the Y position is going to be 0. So this is the X position. Basically, we're saying that we're on the image. I'll just pull it up again. So we're saying that on this image, we're starting at a certain X position, which let's just assume is 0. That means we'd start here. And then the Y position is also 0. So we're starting there at the bottom left-hand corner. So that's your X and your Y. And then the next two values are your width and your height. So basically, we're kind of like saying, here's the origin point, 0, 0. And now we're giving it a width and a height. But the width and the height are normalized. So we're saying 1F, 1F. So that's the top right-hand corner. But basically we're saying that we start somewhere. Let's just assume for argument's sake that it's 0, 0, and then we go in the full width of the image. So if we're at 0, 0, that just goes from this bottom left hand corner to this top right hand corner. However, if we are here, then the full width of the image goes past the end of the image, but because we've got it set on repeat, it comes back round to here. So let's just see that in action. We go back into Unity and we put our compass script on something. Put it on the compass. It doesn't really matter what it's on for now. And then we want to drag our FPS controller into the player transform, and then the compass image is on this very same object itself. And if we press play, we can see our compass moves. It's that simple. And if you can see, north is kind of facing this tree here, straight forwards. And if I spin right round, back to this tree. So it's basically 360 degrees locked to that image. And that's it. That's the end of the video. No, I'm only joking. So that's fine, but we want to do a bit more than that. So we're going to create a new script. And what we're going to do is we're going to add some quest markers. So we'll just call the new script quest marker, and we'll open this up. So the first thing we'll do is get rid of these. We're not going to need them. And once again, we need to include the UI namespace. And then we're going to create a public sprite, which we're just going to call icon, a public image, which we're just going to call image. And then we need a public vector2 position, and this is going to be a get value, and all we're going to do is return the transform position of our quest marker but as a vector2, and we want the x and the z value. So we say get return new vector2 transform.position.x transform.position.z even. And that's that. So if we go back into Unity now, and we, let's just switch back to 3D mode here. We're going to create a random 3D object. It really doesn't matter what it is. We'll create 3 of these. So we use a sphere, put it somewhere down near ground level. As you will see shortly, it doesn't matter what the actual height is. That's why we switched it to a vector 2. But we want to be able to see it from the player's perspective, so we don't want it floating 60 feet in the air. So we'll just hover it about there. That's close enough. Call it quest marker. And we will add our quest marker script to it. So let's duplicate this twice, and we'll just spread these around the map. So we'll put one, let's switch to top view, make it a little bit easier. We'll put one there, and one over here. Now we need to set the values for these ones. So the image we can ignore. It's public because we need to access it from another script, but we're going to be setting it in code, so we can ignore image for now. Icon, however, we need to set. So one of the asset packs that I got, which was free, it's a very good asset pack, is this RPG inventory icons. I know it's inventory, but it'll work fine for what we're going to do. So we'll grab a few close enough looking icons for what we're doing. Book is a good one, so we'll use book. And just for the sake of clarity, we will rename this book marker. And then what's another good one? Bag, yeah, that one will do. Drag that in the icon, rename this to bag marker. And then final one, coins. Seems as good as any. Oh, no, actually we use gem. We'll put gem there. Gem marker. So those are going to be our 3 quest markers that we're now going to display in our compass. So the first thing we need to do to make this happen is we need to go under our compass and we need to create a new image. And we're going to keep the position 0, 0. We're going to keep the pivot 0, 0 and the anchor in the middle. We're going to set it to, I'm going to go 40 by 40, so it's just a little bit larger than our compass height. And then we are going to rename it to quest icon. And then we're going to find a prefabs folder. Do we have one? We don't. We're going to create a prefabs folder. And then we're going to drag this quest icon into our prefabs folder, and then we're going to delete it because we don't need it now. If we go back into our compass script, we need a reference for the aforementioned prefab. And then we'll just drag that in now so we don't forget later. Now, back in here, we needed a list. And that list is going to be of quest markers, which we will just call quest markers. It equals a new list quest marker, and then we need to create a function for adding to this list. So we're going to make this public. Now this doesn't affect this tutorial because we're only going as far as making the compass itself, but if you were to implement this system in your game, the reason you want this to be public is because you're going to be adding quests from externally. So you're not always going to be calling this function from inside this script, so that's why we're making it public. Public void add quest marker, and it's going to take in a quest marker. And the first thing we do is say game object new marker equals instantiate, and we're going to use the icon prefab And by only giving it one more value of a transform, we automatically assign its parent. So we're going to say compass image dot transform. So that means that it will automatically be a child object of the compass image. And then we're going to say marker dot image. So remember I said we were going to set this in code. Well, here we are in the code and we're about to set it. New marker dot get component image. And then we want to set the image dot sprite to the icon value that we put in our script. And then finally, quest marker dot add marker. So we're adding it to our list. Sorry, that was quest markers. So as you could probably guess, we're going to iterate through this list and update all the quests in that list to show icons on our compass. But before we can do that, we need to be able to accurately show the icons on the compass. So if we go up to the top, we're going to need a value for this. And this is going to be called compass unit. And then in our start, which we need to create, we're going to set this value. And the way we set the value is we say compass unit equals, and we want the width of our compass image. And we get that by saying compass image dot rect transform dot rect dot width. And then we divide that value by 360. And what that's doing is that's getting the width of the actual compass. So if you have set your compass width to be a lot wider or a lot shorter, then obviously that value will change. So I can't just put 400. I mean, I could just put 400. That would work fine for me. But if I ever change the width of my compass, it would break it. So we're getting the width of our compass image and we're dividing it by 360. And what that does is it gives us a unit in screen space that is equivalent to 1 degree of rotation in the real world. So if the player turns 1 degree, that equals a certain amount of screen space on the compass, and this is that value. And the next, we need a way of getting the actual position, the vector2 position of our icon in the compass. So we'll do that using a vector2, which we'll spell correctly, and we'll call it get pos on compass, and it will take in a quest marker. So the first thing we want to do is get the player's positions, but in a way that we can use them properly. So we're going to say vector2 player pos, and it's just going to equal a new vector2, and then we're going to get the player.transform.position.x, and then player.transform.position.z. So that's a vector2 of the player's position, but with the x and z value only. And then if we just copy that, and down here we want to put forward. So this is this is going to be a vector2 version of the player's forward vector, and we're just going to change position to forward. So that gets us the player values we need. Next we get our angle. So float angle equals, and fortunately vector2s and vector3s, vectors in general, already have a handy function to help us get this angle, and that is vector2.signedAngle. And what we want to do here is we want to get a marker.position minus player pos, and then the second value is player forward. So what's happening here is marker position minus player pos gets us the direction from our player to the marker. So whichever way, if we're facing straight at that marker, it's going to be the same as player forward. However, if we're facing 30 degrees off to the left, it's going to be facing 30 degrees off to the left. And then player forward is the way that we're facing, and signed angle will give us the angle between those two directions. And then we can return a new vector2 compass unit times angle. So whatever that angle is that we get from signed angle, we're timesing it by our unit, our compass unit, and that gives us the amount of space that angle represents on our compass. And then the y value is just 0, because we're not changing the position up and down, it's always going to be 0. Now to actually handle these, we go up to our update loop, and we're going to say for each quest marker in quest markers. And all we need to do is say marker.image.rectTransform.anchoredPosition equals get pos on compass, and we pass in the marker. So that's all the code we need. Now we just need to have some actual quest items to test it with. So let's just put some temporary references. Obviously you would, in a proper game, you would add them as the player encounters them or whatever, but for now we're just going to put some temporary references up here, and we will add them in a start function. The public quest mark, I'm just going to call it 1. It really doesn't matter what we call it. And then down here, add quest marker 1. And it's important that you go through this function rather than just adding it to the list, because if you just add it to the list, an icon never gets created in the compass. So let's just drag our quest markers into those temporary references and run that and see what happens. And as you can see, we have quest items and they move around with the compass, but do they move? Yep. And as you can see, they move as we get closer to them. So let's head towards this book one here. There we go. And we can run off over here to the gem one. Which should be somewhere around here. Oh, there it is, hiding behind a bush. So we're going to make one little adjustment to it just to make it a bit more finished looking, and that is an idea of distance. So it's all well and good having them on the compass, but it would be nicer if you had sort of a vague idea of how far away you were. So let's start off by adding a max distance, and this value is just going to be basically at some point it will disappear off the compass. You don't have to have this, but it will. Well, actually you do have to have a max distance. You could make this an extremely large max distance so that it covers the entire map, but for the way that I'm doing it to work, you do have to have an upper limit to the distance. So I've been playing around with this a little bit and I found that for this demo 200 is fine. So our max distance is 200. Above 200 away from the player and it won't show up on the compass. And then if we go down to our for each loop, and down here we're going to say float dist equals, I'm going to say vector2 dot distance, and it's going to be a new vector2, and we're just going to get the player dot transform dot position dot x, player dot transform dot position dot z, and then the other value is the marker position, and then we need a scale value which is going to equal 0 by default, and we're going to say if distance is less than max distance. So basically what this means is that we're only doing anything if the scale is less than max distance. If it's over max distance, the scale is going to be left as 0. But if it's under max distance, we're going to set a actual value above 0. And that value is going to be scale equals 1f minus, and then it's distance divided by max distance. So what this is doing is basically, this here is just getting a percentage. So that's going to return in a normalized value, so between 0 and 1, how much of a percentage distance is of max distance. So this would break if distance was greater than max distance, but distance can't be greater than max distance because we're only in this loop if distance is less than max distance. And then the 1f is, because it's a normalized value, it's always going to be between 0 and 1. We want to reverse it because otherwise it would go the opposite way. It would get, what we're going to do is we're going to change the scale of the icon so that the further away you are, the smaller it is. Without that 1f, it will go the other way around. It will get smaller the closer you get to it. So then finally we say marker.image.rect_transform.local_scale equals vector3.1 times scale. And then if we go into here and we maximize this, because hopefully this is the last time we'll need to play it, assuming nothing went wrong, you can see the icons are a little bit smaller. And if I run towards the gem one here that we now know is hiding behind a bush, you can see it gets bigger the closer we get. And the other ones are shrinking away. So the bag one there is the furthest away. Let's run towards that one and watch the other icon shrink. It's over there, we can see it. Boom. And that is our quest compass. And obviously there's other things you could do to it. You could make it so that they fade out was easily enough. You just change the alpha value rather than the scale, or you could have it so that they fade out and shrink. There's all sorts of things you could do. You could put a distance on there if you wanted. Yeah, it's a fairly simple, quite straightforward way that makes your RPG game a little bit easier to play. So that's it for this video. If you enjoyed it, all that's left to do now is to thank my amazing patrons. As always, Professor DJ gets an extra special thanks for being an extra special supporter, but you're all very much appreciated. This has been a mental year, 2019, sorry, not this year, this year's just begun. 2019 has been an absolutely mental year. I can't believe that I'm creeping up on 2,000 subscribers already, and if you can't help with the Patreon, the best thing you can do is just share the channel and like and subscribe if you're not already, and all the other stuff that YouTubers say, ring that bell and whatnot. So yeah, thanks a lot. We'll be back next week with another video, hopefully a Minecraft video, but we'll have to see how it goes. And yeah, bye bye.